Okay, question.
Yes.
This Sharnetta, I just wanted to let you know I sent my answers, but I took a picture of question B with my answer and I sent it to your email.
Yes, that looks good.
Okay.
Okay, so today we study inequalities. Uh, Inequality means we don't have equality, right? We have inequality. We will learn more about that right now. So usually we study linear inequality, linear equation and linear and quadratic equation. Remember that? So if you have linear equation, let me see where's the oh sorry, why I just want to hit the this one. Okay, so linear equation, that is the equation of a straight line. Any straight line divides the plane into two parts. Is that correct? So usually here, for example, you have the y equal to ax plus b, right? One of them would be, for example, right? Not exactly, but this is equal. So somewhere in here should be greater than, or somewhere in another part would be less than or part one. Means one should be. So you have three cases: greater than, less than, or equal. And equality happens when your points are on straight line. Does that make sense? Similar to the case of linear equation, you have quadratic equation. Quadratic equation describes some parabola. Is that correct? Uh, and that is y equal to ax squared plus bx plus c. And of course, any problem divide the plane into two parts, right? Actually, three parts, right? The one may be greater than, so less than in here, and then equal in here. So what does it mean? Look at this. Uh, greater than, for example, if you have one part x in here, right? That is the value, the function value, the y equal to ax squared plus bx. All points in here will be with the y greater than the y value on the graph. Is that correct? Yeah. So similarly, you have less than is almost the same. So we have y greater than ax squared plus bx plus c, and y less than ax squared plus bx plus c. And this is almost similar. You have y equal to ax plus b. Sorry. Uh, keep. Uh, sorry for that. Oh my goodness. But that is about equality inequalities. Does that make sense? Uh, so that is the purpose of this topic. So how to solve all these inequalities and how to express solutions and how to determine which one is corresponding to bigger, which one is corresponding to less than. Does that make sense? We learn this in here. Okay. Uh, but firstly, eraser. They don't let us to erase. Uh, I want to erase this. Interesting. Cannot erase. But anyway, so we need to learn how to solve them and how to express the solution. Firstly, let's talk about intervals, right? Intervals. So you say interval A and B in here. If you have this one, so that is just closed interval. That means two and at that endpoint is included in the interval. Does that make sense? And why I cannot erase this? Oh yes, right here. So there's not. Sorry for that. I cannot erase this. Oh my goodness. Anyway, you have closed interval in here. It says closed interval means 2 and 4 are included. So you might think about this one. This is A and B and close. So you use this notation and you include 2 and 4. So if you have open intervals, I mean, like this, and 2 and 4 are not included. So you do almost the same with the A and B, but 2 and 4 are not included. So you use that. I hope you learn all this from high school. It's not that we need to spend much time. Half open, half closed intervals, almost something here, right? Okay. So that is geometry of those, right? Notations. Open interval, close interval, half open interval, half open again, and sometimes they write infinity here, right? A infinity. So it's corresponding to x greater than a. That means here you have an a, and then here is infinity. So and the interval a infinity, but a is not included. So you have something like this. Yeah, here we have negative infinity. Here you have negative infinity, and here you have negative infinity and positive infinity. Is it? And that is just very quick reminder about that. All right, now let's write inequalities using interval notation. Okay, so first one would write each inequality using interval notation in here. The first one, negative 2x, negative 2 less than or equal to x, and less than or equal to 4. So you see that negative 2 and 4 are included. Just practice a little bit about it, and then we get used to it, right? So you write here. We use interval notation. So I have negative 2 and 4, but negative 2 and 4 are included. So that means this should be closed interval, right? Closed interval. Answer for the second is right here. X greater than 6. So what does it mean? You have 6 in here, greater than, right? Is that correct? So I have 6. Here should be infinity. I can write that is 6 infinity, and 6 is included. We don't include infinity because that is like infinity, okay? And x less than negative 3. So I would like to do geometrical right here too. So negative 2 and 4. So you have 2 and 7, but 2 and 7 are not included. 6 infinity, negative 3 right here, but less than 3 is not included. So I have this one. I can write that is negative infinity to negative 3. Is it? So it's pretty simple. Is that correct? Next one, please. Do that real quick. Write each interval as an inequality involving x. So negative 1, 2. Let's do 4, right? We express the interval as inequality involving x, and then just draw that. So with negative 1, 2, I have negative 1 x2, right? So I have to express 2 and 4 in here, and then I see if we have closing here, so that means here less than or equal. If I have opening here, it's just less than. Does it make sense? No. So if grab them, you also grab negative 1 and 2. 2 is included, so I write like this, but 1 is not included, so I write like this. Sometimes this method is extremely useful. You see that in the future. It is extremely useful. Okay, so next one, negative 2, 0. Again, you write negative 2 and 0. With -2 in here, we have close. That means -2 and 0 are included. So you write less than or equal, less than or equal. I also expressed on the number line -2 and 0. They are included, so I get that. Okay. Next one. You have 5 and infinity. No. 5 is not included. That's why you have x greater than 5. Or you can write less than infinity, right? But usually we don't write it. Does that make sense? So we just write x greater than without negative, without equality in here. So I write in here 5 and here infinity. Last one is almost similar. 1. Everything from the left of 1 is not included. Is it correct? So we can write x less than 1. So this is 1. Negative infinity. Is it? Okay. Very simple. I would say that. Any question about this? Okay. This is the one we talk about, properties. So the negative properties square of any numbers is non-negative. This is obvious. But the inverse operation is more difficult. Okay. Addition. For real number a, b, and c, if you have a less than or equal to b, then a plus c less than or equal to b plus c. That is obvious, right? If you add to both sides, some number, you don't change the inequality. And this is almost the same, right? It's almost the same. So, say if you add or subtract from an inequality by a number, you don't change you don't change the direction of inequality. That means you take both sides of an inequality, you add or subtract, But if you take two inequality and subtract them, we have to be very careful with that. Does that make sense? What do you mean? I'm explaining here. For example, you have -2 less than -1 less than, I'm sorry, greater than. Oh man. -2 greater than -1. Is that correct? You add some number to this, to both sides. It's okay. You subtract from that, from both sides, some number. It's okay. But you take, for example, you take 1, you subtract both sides. That is different. Does that make sense? So if you write, okay, from here, no, it does not imply that 1 minus -1 greater than 1 minus -2. It's wrong. You don't have right to do that. So you see, it's all obviously wrong. So you have 2 greater than 3. You see that? Does that make sense? That is different to the case. You have, okay, I write here -1 greater than -2. But you get -1 minus 1 will be greater than -2 minus 1. So you still have that in the direction of inequality. You don't change that. But you take some number and you subtract, both sides. The inequality will be reversed. Don't forget that. The inequality will be reversed. Okay? So be careful with that. Does that make sense? So with this addition, okay, again, right? When you look at this, I'll tell you what I treat linear equation. We do almost the same thing in here. What does it mean? X less than -5. Then x plus 5 less than -5 plus 5. And that is 0. So I explain like this. If x less than -5, and you want to bring terms from one to another side of inequality, you just need to change the sign. How about that? Remember that? So I just bring -5 into this side. I change the side. So I get x plus 5 less than 0. So we play, that game like for equations. You might bring one term to another term, right? In inequality, and you just change the sign. Does that make sense? So, yeah, in the end, of course, you get the same, x plus 5 less than 1, but explanation is a little bit different. So here, x greater than 2, you want to write x minus 2, that's 5. You bring 2 into another side, you change the sign. You get x minus 2 greater than 0, done. You have nothing in the right-hand side part of inequality. Does that make sense? Okay. Now multiplying an inequality by a positive number. So if you multiply both sides of an inequality by a negative number, a positive number, so you don't change the direction of the inequality. So the inequality is still there. Let's say you have 3 less than 5, right? You multiply by 2. What do you get? You get 3 times 2 is 6, 6 less than 10, right? It's obvious. But what happens if we multiply both sides of an inequality by a negative number? How do you think?
If it's negative, it would be wrong.
The inequality.
For that.
Yes, the inequality will be reversed. So let's do this. 3 less than 5, right? And you multiply both sides by, let's say -1. Is it correct? Just -1. Okay. So you got -3 will be greater than -5. Let's see. The inequality will be reversed. Is that correct? Does that make sense? Don't forget that. That is the common mistakes. Sometimes you forget about that. You have right to multiply by a negative positive, but you have to pay attention on the direction of inequality. Multiplication on, by a positive number don't change. But if you multiply by a negative number, you get a reverse, like this. Because this is -2. Not only, if you multiply by any negative number, the inequality will be reversed. Does that make sense? Pay attention on it. That's why I just told you, right? In the example I just told you. So let's say 3 less than 5. What does it mean? 1 minus 3. Okay, how to do that operation, right? Of course, 1 minus 2 will be greater than 1 minus 5. How to do that? So what is 1 minus 3? I say minus 3. Firstly, I need to multiply this by -1. Is that correct? And then I add 1 to both sides. This is how I do subtraction. Is that correct? So if I multiply by -1, I get -3 greater than -5. And then I add 1 to both sides. I don't change the inequality. From here, I get 1 minus 3 greater than 1 minus 5. So I'm writing here. You see? So when you subtract 3 from 3 by 1, you are okay. But you subtract 1, but you do subtraction like 1 minus the whole thing. So you totally change the inequality. Does that make sense? That changed because you multiply by -1 at this step. And your inequality was reversed already. Does that make sense? Okay. So with multiplication in general, we have the following. You have some inequality A less than B and C is greater than 0. Then when you multiply both sides by C, you are okay with that inequality, right? You don't change anything. Say, but if C is less than 0, so the inequality is reversed. Just general rule. We move step by step from very easy stuff to a little bit more complicated, right? still now we don't solve any general inequality right now. So, for example, this is a very simple one: 2x less than 6. You want to get x, right? Want to get x? We solve for the x. So you want to eliminate 2, is that correct? How do that? Just divide both sides by 2. Right? You divide both sides by 2. Are last time I think I explained about cross multiplication, cross division. Do you remember that? It's simple, just divide both sides by 2. You don't have to write this again. You divide 6 by 2, you get 3. And since 2 is positive number, you are good. You don't need to change the direction of the inequality. The inequality is not reversed because you divide by a positive number. Does that make sense? Working with positive numbers, we don't have any issue. Agree? So you get x less than 3. Or sometimes you write, or it's negative infinity to 3, and 3 is not included. With the second one, x over negative 3 greater than 12. All right, you want to eliminate negative 3. Now you have a negative number. So the easiest way is just multiply by negative 3, right? Multiply both sides by negative 3. But when you multiply both sides by a negative number, the inequality will be reversed. So we remember that rule. I just delete everything x. The inequality greater than will become less than in here. And that's it. And we do, our operation. So x less than negative 36. Because negative 3 times 12 is negative 30. Does that make sense? If you don't want to work with negative number, I will do the following way. Maybe it's not a good way, but it's fine. I don't like negative numbers. From x over negative 3 greater than 12, I have x over 3 less than negative 12. That's it. I just change the sign of negative 3, right? And of course, I reverse the inequality in here. And then now I multiply both sides by 3, I get what I need. So, this way, let's say we try to avoid negative coefficients of x. In the original one in here, the coefficient is negative 1/3. Is that correct? You divide by 3, but basically, the coefficient is negative 1/3. X over 3 means 1/3 times x. Is that right? So if you want to avoid, working with negative coefficients, you might do like that. Just multiply both sides by negative 1 and change, right? You get negative 1/3 in here, and then you do with positive numbers. Does that make sense? All right, next example. Negative 4 greater than negative 8. Again, negative 4, right? You divide both sides by negative 4. You reverse your inequality. Don't forget that. So we don't need to care about this anymore. Negative 8 over negative 4 is 2. Greater than will be less than. We have x less than 2. Okay, I think the last example is almost the same. Okay, so this is about, you take the inverse. If a is greater than 0, the inverse is greater than 0. If a is less than 0, the inverse also less than 0. So they have the same sign. That is obvious. By the way, I think this is interesting. This direction is easy to understand, but this direction may be cause some difficulty. So I look at this from the point of view of the size. Look at it. That is important when we study inequality involving fractions. So 1 over a greater than 0. It is equivalent to the case 1 times a greater than 0. I would say like this, 1 over a greater than 0. In general, I can write like this, a times b greater than 0 is equivalent to a over b greater than 0. Of course, in the case when b is not 0, right? Does that make sense? So not here, not only one, you may change by b. It says the product, when the product of two numbers is positive, they are of the same parity. Negative or positive. Does that make sense? They have the same sign, let's say. If the product is positive, they have the same sign. If the product is negative, they have different signs. One should be positive, one should be negative. Does that make sense? It is important. It is important. We'll solve problems later, but that happen not only for 1 over a, for over b over a. So if for b over a greater than 0, then a times b greater than 0. You see, like that. Does that make sense? If a over b is less than 0, a times b will be less than 0. Okay. I think we just solved this problem, and then we're good for today. We will continue this topic next time. So simplifying both sides of the inequality by combining like terms and eliminating parentheses. So we know how to work parentheses, right? With the first parenthesis, x plus 2, there's nothing, we just erase them. In here, we distribute this, we get 5x. So basically that is 2x plus 5x plus 5. 2 with 5x will be 7x. Right? Will be 7x. And then you simplify like term. So let's say you can write, we have 1x in here, we have 7x in here. You simplify 1x. You cancel 1x. So basically, you have what? You have 6x less than 3. How about that? Is that correct? You cancel 1x from both sides. And you cancel 5 from both sides, right? Is that right? So a will become 3, but with the 3 greater than 6x. That is equivalent to 6x less than 3. Is that right? So, and then you divide both sides by x, you get x less than 1/2. I don't know, divide both sides by 6, sorry. Okay, so we just have very basic operations over here. It's not that bad. Our two problems are similar, so I think we can solve it here. Okay, so next time will be more interesting.